Hello everyone, our project is AI medical imaging for diabetes retinopathy. Now let us see the prevailing problem, the solution that we have provided and how our solution works. The prevalence of diabetes mellitus in sub-Saharan Africa is anticipated to escalate from 19.4 million in 2019 to 47.1 million by 2045. This surge carries a significant risk of diabetes retinopathy, affecting 35% of individuals with diabetes mellitus and 10% with vision-threatening diabetes retinopathy. Traditional medical diagnostics for diabetes retinopathy diagnosis face challenges, notably due to insufficient health structure, especially in the rural areas. The prevention of avoidable blindness, as emphasized by the World Health Organization, hinges on early detection and treatment of vision-threatening diabetes retinopathy. Addressing these challenges is pivotal for ensuring equitable access to comprehensive eye care and fostering a healthier future. In the African region, providing effective care for diabetes retinopathy faces notable challenges. A shortage of qualified ophthalmologists limits comprehensive diabetes retinopathy care, exacerbated by a lack of specialists with training in diabetes retinopathy management. Insufficient opticians and ophthalmic clinical officers, especially for opportunistic screening and limited training in fundoscopy, further hinder the effective care. The absence of systematic screening programs results in delayed detection, while limited access to essential imaging technologies compounds the challenges in accurate DR assessment. Addressing these barriers is crucial for enhancing the diabetes retinopathy care in the region and ensuring timely accessible intervention. Here is the statistics for the need of AI medical imaging application. Here are some other problems which makes the AI medical imaging application highly essential. The problems like subjectivity and scalability issues, and there is limited availability of experts, and the diagnosis process is time consuming, lack of standardization, and the variability in interpretation of the disease, and then the data management and communication. So to address all these problems, we have provided a solution. Here is a solution to the problem. We have developed an AI model which analyzes the eye scans and detects the diabetes retinopathy and classifies the results into 5 categories, namely no diabetes retinopathy, mild, moderate, severe, and proliferate. We have implemented a database where the patient information and the eye scans is stored. With this, we have created a concise visualization for a detailed summary report on the level of diabetes retinopathy. After analyzing the level of DR, a detailed patient report is generated with vital details such as the patient ID, gender, date, the eye part which is scanned, and the level of diabetes retinopathy. And this gives an improved understanding for the patients and the doctors. In future, we have planned to introduce a notification system in case of severe diabetes retinopathy through email and SMS, which ensures the timely communication and a proactive healthcare management. Here is the architecture representation of our AI medical imaging application and the model. Here is the process flow diagram of our AI medical imaging application. In the diabetes retinopathy diagnosis, firstly, the user uploads their eye scan image, and then our AI model predicts the level of diabetes retinopathy and categorizes into 5 categories as mentioned earlier, like no diabetes retinopathy, mild, moderate, severe, and proliferate. After analyzing the level of diabetes retinopathy, a detailed report gets generated where this report can be downloaded by the user, and then the database can be visualized for a better understanding. In future, we have planned to develop a new feature called Radiology GPT, where in this Radiology GPT, users can upload any scan image and the medical vision language model analyzes the uploaded scan image. And then through the linear transformation, our medical LLM generates feedback on any scan or radiological images that have been uploaded and provides suggestions to improve the prevailing condition. Here are the tech stack that we have utilized in our project: TensorFlow, Pandas, Streamlit, OpenCV, Keras, Python, CNN, and Vicuna LLM and Medclip. Here are our goals and objectives. Our goals is to enhance the diagnostic accuracy through precise categorization of the diabetes retinopathy, and then to ensure accessibility. Even the non-medical users can upload their eye scan image and receive feedback to the generated report, and then to streamline the diagnosis process. Then to address the communication challenges, we have planned to introduce a notification system where the users will be notified in case of severe diabetes retinopathy, and then our aim is to enable the early identification of the DR disease and promote a proactive healthcare approach. Here are the innovation in our project. The first innovation is the real-time analysis. The highly time-consuming DR diagnosis have now been changed into a 1-minute diagnostic process. So this ensures the swift results and enables the immediate decision making in the healthcare scenarios. And then the automated report generation. Here, the report generation have been automated, which saves time for the healthcare providers and streamlines the documentation process. Here are the use cases of our application. There are several use cases of our application. Here are some: the primary health checkups, in telemedicine services, in urban health centers, in emergency situations, and in health awareness campaigns. Here are the uniqueness in our project. Our model is a pioneering model for diabetes retinopathy diagnosis, and then the holistic eye scan image feedback gives direct feedbacks on the eye scan image through the generated report. And our application is accessible even for the non-medical users, as the common people can upload their eye scan image and get insights in the form of a report, and then the community health dashboard gives a broader understanding on the health trend. In future, we have planned to enhance the interoperability standards to integrate with diverse healthcare system and to expand the language model capabilities to a wider array of medical specialties, and then to extend the medical imaging application to cover additional common radiology scans and diseases, broadening the platform's diagnostic reach for improved healthcare outcomes. Here is the demo AI medical imaging application. Now let's go on to the prediction page. Here the patient can enter the DICOM information such as the ID, where the patient name is provided, then the sex of the patient is given. Next, the age is provided, then other data like date, the eye patch is given. After that, the scan image is uploaded. Now, the report of the patient is displayed after examining the provided information. In the backend, the AI inference engine will examine the patient's eye scan provided and classifies into different classifications such as no DR, mild, moderate, severe, and proliferate, and generates the report. The report can also be downloaded here. Now, let us go into the dashboard page. The dashboard gives the view of AI pipeline at the backend. We can initiate the batch inference here. The summary and analytics of the test run are shown here. Here, we could see the data summary of all the patients in the database based on the information which is provided in the prediction page. Here in the backend, the AI inference engine processes all the patient report and then provides us the summary. And here is the data summary of the data which is provided in the prediction page. Now let's go into the reports page. Here, the reports that are generated by the AI inference engine can be viewed here. Here, the patient ID is given and the examined eye report which is generated by the AI engine is written. And here is the report generated by the AI engine. The report can also be downloaded here.